Welcome back, everybody. Today I'm going to show you a bunch of miscellaneous modeling techniques, and by that I mean things that you don't really need to use most of the time but will come in handy for certain situations. I'm going to show you how to do Booleans. I'm going to show you how to use Nurbs Curves and Nurbs Surfaces, and we can convert those from Nurbs to Polygons, which is necessary if you want to continue to model them effectively, and I'll also show you the text tool. So a bunch of stuff that's really useful, but you won't be using in everyday modeling situations. So first, let me show you Booleans, which is tremendously useful, but you're going to hate me for not having shown you earlier. Although if I had shown you earlier, you would have messed up lots of your models. So here I'm going to take two primitives, and I'm going to intersect one with the other. So I'm going to make the cube large enough to cover the cylinder, and then I'm going to grab the cylinder and scale it until it pokes through the surface, and I'll just turn it on its side as well, so that it is perfectly in line with this cube. So here's this cylinder sticking through both sides. I can make it as long as I want. Let's give it a little bit of length there. So what Booleans will allow me to do is to treat one of these two objects like cookie dough and the other object to act as a cookie cutter. You want to make sure that you have only two polygon objects selected. Don't do it with several. If you have to do this several times, you're going to want to make duplicate objects and wait for their turn. So do them one at a time. And what this is going to do is to essentially punch a hole through one of the two objects, depending on which you select first and which you select last. Okay, so in this example, I'm going to select the cube first and the cylinder second. And then we're going to need to use our Polygons menu, Mesh, Booleans, and there are these three operations that we can use: union, difference, and intersection. So I'll go through them one by one to show you what they do. For union, the two objects are going to be combined, but whereas there used to be cylindrical information going through the center, now there's nothing. Now it's completely sewn together with the cube, and in fact, if I move these vertexes, you can see that it's going to affect this face. Well, you can kind of see that. You may already be seeing one of the problems is that although this combines the two pieces of geometry, it does not create edge loops, and it does not draw that information into the surface. It creates horrible, gigantic n-gons. Okay? That's the reason I didn't show you this stuff earlier, because although it is convenient, you need to use it responsibly and fix these surfaces, or you'll have huge n-gons. It won't be able to be imported into most game engines, and you may get rendering artifacts from that. Okay, so that's union. I'm going to undo until I see that little line go away, and that should mean that they're back, just like that. I'm going to select again in the same order, cube, then cylinder. Mesh Booleans difference is the one I was talking about earlier. This will punch a hole straight through the cube. So this is a very convenient way to get a nice hole right through an existing face or existing piece of geometry, no matter how detailed it is, by the way. And to fix these faces, what you would have to do is go through with the interactive split tool maybe, or you could extrude edges and merge those vertices and merge them to existing corners and perhaps make edge loops going through the center. You see, as soon as I do that, I get this terrible, weird looking geometry. Let me see if I can fix that there. So if I delete these faces just completely away, I can use my secondary method of grabbing some of these edges, extruding them. Let's move them out like that. And then I can just merge the vertices to that existing corner and close whatever resulting faces I get at the end. So merge vertex tool, merge, merge, merge. I can see that there's some sort of weird double edge going on there. There we go. So for some reason, I've got an extra one. Let me see if there. Okay, there we go. And I would just go around the rest of it doing the exact same thing. So as you can see, if you want this to be completely finished and a final piece of geometry that you can continue doing operations to, it's going to take a lot of work. It's not just a one command operation, so you have to use this responsibly. If at all possible, try to use a different method first. Although this one is fast, it will be much slower in the long run because you're going to have to fix up all of this geometry information. So let me just undo back to before I did those operations. Hopefully I've got enough undos. There we go. Back to before, and so I can show you the last Boolean method. So once again, cookie dough, then cookie cutter, which is like how I like to think about it. Mesh Booleans intersection. will leave you only the parts of that geometry which are overlapping. So as you can see, this looks like a normal cylinder. The only difference is that there's no edges or vertex in the middle of these caps. That would be really easy to fix though. We can just grab the caps and poke face, and that should be perfectly fine. But now it's just like a default cylinder, so that's not very exciting. Let me show you what happens if I select them in the opposite order just for the sake of argument. Here's the cylinder first, cube second, mesh, Booleans, intersection, same, mesh, Booleans, difference, different. It cut a hole out of the cylinder instead of out of the cube, and mesh, Booleans, union, same again. Okay, so really only the second command, difference, matters which one you select first and second. So just make a note of that, that's the one that really matters. And that's the one oftentimes that we most frequently use, although I guess you could make like a little Lego shape with union or something with a little tab on one side if you really wanted to. So that can be labor saving, just be aware. Use it responsibly, make sure that you're prepared to fix any problems that might occur. Alright, the next tools I want to show you are useful if you want to make piping or cord or something that needs to move out in a sort of snake-like manner and have a certain profile shape to it. But it requires that I show you how to use curves. Up in the Create menu, we've got CV curve, EP curve, and Bezier curve. You can also use pencil curve as well, but I'm only going to show you these three. And this is an introduction to Nurbs. Now, what Nurbs are a type of geometry that is essentially squishy. So let me show you a Nurbs sphere. You can see it looks very, very round and smooth with a minimal number of divides going around it. And when I right-click and hold on it, instead of getting the normal menu, we get isoparms, object, hole, surface UV, surface point, surface patch, control vertex. I'm going to grab control vertex to show you that these points are actually floating off the surface, and it's because these are kind of like a target for the surface and not actually a surface point. So it's not like a vertex, but it's as close to it as you can get. The surface is going from one of these points and trying to head in this direction towards this object, but ultimately aiming at the next one. And so it sort of curves along and averages all of these points together. So if I push this down into it, you can see it kind of creates an S curve as it flows along there. So the curves are very much like that. In fact, they're exactly like that. They just don't make the surface automatically. And we can use them to make geometry which is much more difficult to make in polygons. So first up here, I'm going to go to Create, CV Curve tool. This will draw on the grid surface here. So if you want to draw it in a certain direction, you should really enter into an orthographic view first. So if I wanted to draw straight down on the grid, I'd look into the top, so I'm looking straight down at the ZX grid. If I wanted this to stand upright, I could look at the front view, which is the YX coordinate. So let's just do that. When I click with the EP, or which one is this? The CV curve tool is the first one I chose. These points are not going to lie on the curve. They're going to average, like I just showed you with the Nurbs surface. So this point is not on, only the first and last points will be on the curve, but the rest of them will just sort of average it out. So as you can see, all of these points, they're trying to head in this direction and then turning halfway through towards the next one, turning halfway through towards the next one. So some of them coincidentally end up pretty close. Most of them are not, especially around a tight curve. So that was just left-clicking, left-click, 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 and when you're done, hit Enter, and you will have your curve. Now editing a curve is pretty easy, just like a polygon object. Just right-click and hold. We've got a few options here. We've got Control Vertex, Curve Point, and Object Mode, and Edit Point. For the most part, you're only going to want to use Control Vertex for these things. So Control Vertex will give you those points back. You can move them around and interactively change the shape of your object. The only downside to it is that it's fairly difficult to judge what point belongs to what part of the line sometimes, especially when they overlap like this. So you can see this point is down here. Even though it belongs to this part of the line, you could very easily mistake it for this one here. So you might want to be careful about that. Though I think that if I use hull, yeah, hull will reveal what point belongs to what, but you can't exactly grab a singular point. You can only grab edges, and in fact a hole is going to extend around the entire thing. So this is more like a roadmap for a curve. This works with Nurbs objects, but for this it's not really very useful. Curve point will allow you to grab a point on the actual curve itself, but it doesn't actually do anything. It will allow you to insert additional detail in certain parts of the curve, but that's it. And eventually it will give you more control vertexes. So here I'm left clicking and dragging. You can see this little red dot as I drag and then yellow when I let go. If I want to add more than one point, I can hold down Shift. So for instance, in this curve I can see that it's very faceted. So I'm going to add a couple points there. Using the surface menu, this is where most of our curve and surface commands reside. I can go up to Edit Curves, Insert Knot, and you can see that little portion of the curve is suddenly much more rounded, and when I choose Control Vertex, now I've got more CVs in this location to mess around with and help shape the curve. And so in any spot like here, maybe over here, that looks a little bit too sharp and faceted, you can do that to get more detail in that region, and that can be a very good idea if you are going to use this for extrusion like we're going to in a few minutes. Let me delete this one, and I'll just go ahead and draw. Actually, let me show you first, before I delete it, that this is in fact standing upright, okay, because I was in the front view. Go ahead and delete that. And we'll go ahead and use the top view for this next one. The next curve tool, EP curve tool, will draw these points on the line, but the curve nature will not necessarily follow what you intend. So here you can see 1, 2, 3 points, and this one is on the line just like the first and second one. But when I make this next one, you can see how parts of the curve are adjusting their shape as I drag it around. That's what I mean by it won't necessarily follow your intention. You can see that the actual bottom of this parabola is like right about here, even though the point that I drew is right there. So don't think of these as maximums or minimums mathematically. They're really just points that reside on the line, and the line is flexible. When you're done, hit Enter. You'll have the same sort of line created as before. And if I right click and hold Control Vertex, we again get control vertices that are off the line. That's just the way that we interact with these. Okay? But the same sort of line is created, so you can use either one of those interchangeably depending on your preference. If I go back out to perspective, you can see this path is laying down on the surface of the grid. By the way, as an aside, if you want to make a three-dimensional path like that of a roller coaster or something, you have to draw it in one of those orientations, down or facing upward, and then go through, grab these control vertices and drag them into their three-dimensional orientation. It's a bit of work to get it to work correctly, but it's best to just do it that way because it's going to be nice and quick, and it will make sense to you if you think about it in a systematic way. So here's our three-dimensional curving line now. I'm going to delete that one, the very last one. Create Bezier curve tool. Bezier curves might be familiar to you if you used Illustrator or Photoshop, Adobe Illustrator, Adobe Photoshop. They're a method to draw lines that can give you both sharp points and curving points and make it very, very customizable. So I'm going to use Bezier curves, and I'm just going to draw in perspective, which will default to a laying down position here. If I single click, I will get sharp points. If I click and drag, I will be dragging the direction that the line attempts to head in before I make my next click. Okay, so you see I can get an oscillating shape if I click and drag, and sharp tooth-like shapes if I just single click. When this is created, it is slightly different. When I go to Control Vertexes, you will see these little handles are created on the points that I used a drag to create. And if I grab those handles and move them, you can see that the line will reshape itself as I move that. That's really nice, but it's not quite all of the strength that this has. You can convert any one of these points from a corner to a Bezier or a Bezier corner. If you grab one of these points, the central point, shift right click and hold, we've got Bezier corner, Bezier, and corner. Okay? Bezier corner will break that handle essentially. You can also do it down here, break anchor tangents. It's the same thing. So Bezier corner here, and now I can move one side or the other independently and create like cresting wave shapes or something like that. Okay, this one right here does not have any Bezier handles, so shift right click and hold Bezier, and now I can move them and shape it however I want to. Okay, so that is, as you might imagine, very, very powerful and convenient. It's not often necessary to use the power of this tool, and so I often default to something like the CV curve tool is my favorite one. Okay, but if you have to make a very, very custom shape, then this Bezier curve tool can be your best friend for that. All right, I'm going to go ahead and delete this line, and I'm going to show you how to extrude along a path. Now this is a very, very convenient method of making things like power chords. You could make like a Twizzler, you know how it has that kind of twisting, kind of ridged feature to it, drill bits, things like that. So first, I'm going to go ahead and create Nurbs primitive circle. And this is going to be like a cross section of my wire if I were to just snip it with like a pair of shears or something. So instead of just making this circular, I'm going to make this interesting. I'm going to grab all 4 of these control vertexes and scale them in. And we could just extrude it like that, but I'm going to just show you a little bit of editing here. Curve point, I'm going to click and drag near these spikes, hold shift, and add more of them. I'm just going to add one on either side of these spikes going around. Just like this. I'm going to go up to Edit Curves, Insert Knot, and when I come back to this, now I've got extra control vertexes, which I'm going to scale out. So this is going to create a very nice custom look for, I don't know, something, 4-leaf clover type shape. But that's what I'm going to be able to extrude along a path now. And that's going to make a very cool looking custom shape. So I'm going to tip this upright 90 degrees because I'm going to draw the path that it's going to take directly on this grid, just some sort of undulating path for an example. Okay, so I'm going to create CV curve tool. My first point I'm going to snap to the center of the grid by holding down X. I just want a solid starting point that I can lock both of these to. It's very convenient to be able to have both of these on the same point, but I'll show you an extra trick for that in a second. And then I'm just going to make some sort of weird path. Doesn't really matter what it is. I could make this 3-dimensional. In fact, let me just go ahead and make part of it 3-dimensional just so that we can see what that does. There we go. Maybe push this one down a little bit. This one down a little bit. There we go. Okay, so 3-dimensional moving shape. These 2 bits are right on the same point in space. So this is at the origin point because I created it there. This one is at the origin point because I snapped it there. That is important for extruding something along a path. If you create something which is somewhere else, or for some reason this cannot be at the origin point, there's a trick for snapping this to a curve. If you hold down the letter C, and you can see this highlight at the top here, hold down the letter C and drag this from the center. Just make it overlap the line visually, let go of the mouse button, not the letter C, and then re-click and drag and it will snap to the curve. Okay, we can start it on this side of the curve or we can start it on that side of the curve. Just make sure it snaps to one of them. It is also sometimes helpful to rotate this to face in the direction that the line is going, although the settings in the extrude along curve function are probably going to take care of that for us. I like to do this anyway just to make sure that everything's taken care of. All right, so the command that we're going to use is inside the Surfaces menu, Extrude, and you can see the tooltip at the bottom of the screen in the left-hand corner says Select Curves, Isoparms, or Trim Edges, select the path last. Okay, so that means we want to select this guy first, this is the profile, then this one second, that's the path. Okay, Surfaces, Extrude, I'm going to open up the option box so we can see what's going on here. Let me just reset that just in case. There we go. And I'll hit apply. And you can see this shape has been extruded all the way along this line. Okay? Some parts of this may be looking a little bit too sharp. Some of them may change shape and look strange. We can add isoparms to a certain part of this if we want to affect that. But let me just undo really quick and show you a couple options up here. Tube is almost always what you want, so just leave that alone. Result position at profile at path is an important one. if these two are not in the same space, okay, like this, at profile, we'll create it from this object, trying to figure out how to line this line up to it. Also, you can see it's kind of picked backwards. It's picked this end of the line to start from rather than that end, I think. But it's a little bit confusing. This is why I snapped them together, because then this option doesn't matter as much. At path, we'll create it here. So it's like this has moved to the path, but as you can see, it's also rotated out of sorts. So if you want a predictable result, make sure these things are together. And then it doesn't matter which one you use. They'll come out exactly the same. Okay? What I'm going to do is I'm going to move this object, if I can grab it. Object. Oh, you know what? I think, nope, I have selection highlighting turned on. I'm not sure why it's not attempting to select this. Let me change to wireframe really quick. There we go. So there's my object. I'm just going to move it off to the side. This is still interactable because it holds the history of its construction with it. So if, for instance, I don't like part of this line, how it's shaped like here, I can grab the control vertexes of this line and move them around and see that interactively changing its shape. So this can help for fine-tuning the particular way that the path has been constructed. Also, if I view the wireframe, there's the wireframe, and I want to add curve points here, so let me add a couple. We should get extra detail on this model as well. Edit curves, insert knot, just like we did before, and there you can see new isoparms on the resulting Nurbs shape. Okay, so that can be a great way to add detail as well. We can edit this directly if I choose isoparm and drag from an existing edge loop. The only thing we get are edge loops in Nurbs, so just bear that in mind. I can tell I need more detail around here, so I'm just going to drag to that area. Go to Edit Nurbs, Insert Isoparms, and you can see I get an extra little bit of detail in that area as well. So either way works, but the result is a nice looking custom cord, rope, piece of candy, whatever it is you want to think of. Okay? This is the type of thing that would be very, very difficult to do with polygons. So use this for railings, for ropes, for wrought iron fence pieces, things like that. Okay? It's going to be tremendously useful to you. I'm going to go ahead and close that off. What we have here now is a Nurbs Surface piece. Okay? It needs to be polygons for most of our final uses. It's okay if you're just rendering a scene. Nurbs will render just fine. They will take on material and surface and lighting attributes as well. But if you're going to do this for game purposes, or if you want to continue modeling this, it needs to be turned into polygons immediately. For instance, the things that we can't do are like extrude faces, bevel edges. We can't do any of that stuff with a Nurbs object. So we've got a menu for that. Modify, convert. There's all sorts of options down here, but it's the very first one, Nurbs to polygons. I'm going to choose the option box menu and show you a couple of the results that we can get from the conversion process. Not every option here is ideal. First, we've got the type triangles or quads. If you aren't going to model this further and you're just trying to convert it, you can leave it on triangles, but otherwise I would strongly suggest you choose quads because it will limit the amount of information, make it easier to handle. This starts on standard fit, and I'm just going to hit apply and show you the resulting piece of geometry. So there's the original down there, and this is the resulting piece of geometry. It's not really ideal. In fact, I never use this option because of this right here. Wherever it thinks that it needs extra detail, it will just subdivide existing faces with no regard for edge flow or the creation of n-gons. And so I don't like it for that reason, and so I rarely ever use it. I'm just going to undo. General is a little bit better. This allows you to set a number of spans in the U and V direction. Now, which is which? That's a really good question. But if I convert this now, 3 and 3, what we get is an object which has literally 3 edges by 3 edges. So terrible. Okay, I'm going to undo. I'm going to turn U up to 20. Okay. What you can see the result is that there are 3 edges along the length of the tube and 20 going around the profile. Okay, so that answers our question. U is apparently the profile, V is the length of the object. So I'm going to undo again. I'll change this one up to 20. So 20 and 20 now. And let's see what we get. Okay, much, much better. Looking at the profile, I think that we could stand to have some more divisions in the U direction. Maybe something like 24 or 28 or something like that. Along the length of the tube, we're close, but again, we need some more. I would say like 30 and 30 is what I'm going to try now. So we'll do 30 there and 30 here. I like this method because it gives me a little bit of flexibility. If the profile is not that detailed, I can turn this number down. If the length is not that complicated, I can turn this number down and thus dial into the type of polygon object that I want. This one looks pretty great. I think we still need additional detail on the length, but the profile is looking fantastic. So I'm going to undo last time here, probably, and I'll do like 48 or so. So this should be, yeah, there we go. More than enough, at least in most cases. We're getting a little bit of faceting right here, but everywhere else it looks fine. More than enough detail to accurately represent this in quads. And as you'll see, no n-gons anywhere, no strange geometry artifacts, because it's strictly doing it based on the number of edge loops created. Okay, so this is a very predictable way to create things. It's my favorite method for most cases. I definitely recommend that you use general. Okay, the last two are count and control points. Control points will create the object based on, literally, just the control vertexes. They will become vertexes and it would become a polygon, end of story. Okay, so unless you want a very low polygon object, you're rarely going to need to use that one. Okay, but you could do it. Okay, so there it is, just all of the control vertexes turned to control points. Count is good if you have a roughly homogeneous object where the detail is going to be spread over the entire thing uniformly. It is just a number of polygons that it will create at the end, and then its attempt to spread them evenly across the surface. So there's 200 polygons. As you can see, our profile detail is completely gone, but it is hugging the shape fairly accurately, and it tries to approximate it as best it can. Let's turn this up to like 1,000. So 1,000 faces will be created, and let's see if we got any closer. We did, but again, the profile shape is pretty much gone, even though it's hugging the shape accurately. So again, let's try 2,000. Closer, not really representing the shape very well, but we are getting closer and closer to the object. I don't like to use count very much if it's a complicated object, especially if there's different areas of complication, like one part that's simple and one part that's complicated, because it doesn't tend to reflect the object very well. That said, this can be a quick option if your shape is rather simple. Like if this was a plain cylindrical tube stretched along, it would probably be fine. Okay. In most cases, though, I tend to use general for these conversion methods. Okay, and this is a polygon just like you're used to now. We can grab some faces and extrude them. We can delete faces other places if we want to. All the normal stuff that you're used to, which we can't do on this Nurbs object. The last thing that you would want to do is to delete this history. And you can just get rid of all of those builder objects. And here's our polygon result. Okay? So that's the extrude along a path option. Very, very useful for certain things in modeling, and a lot more convenient than doing it with polygons would be. Okay, I showed you a little bit of Nurbs Surface things, how to use CVs and isoparms. I'm going to show you the last thing is the text tool. We go to create text. We've got this option box here. You almost always need to open this option box, okay, to type in the resulting text. We can set a message in type. So I'll say test words. You've got a font choice, and then we've got a type at the bottom here. Let's choose our font. The thing to keep in mind here, and I'm just going to turn this up as big as possible so you can see the letter shapes here. The thing to keep in mind is that this is going to attempt to make polygons out of this letter shape. So if you have a very, very fancy font, it's not going to work very well. All of these ones so far have been pretty reasonable. These would work. The more blocky it is, the easier it's going to be to convert. These are a little bit more complicated, but very reasonable. Let me find a strange one. That would be fine still, although not all the details would come through. This would probably be a nightmare. Okay, it's very, very thin, very, very curvy. I'm not so sure you could make a good polygon shape out of that. This one would be a nightmare. You can see all of the overlapping areas of solid and transparency. All of those would try to make different polygon faces. It would just be horrible. That one would be horrible. That would be fine, 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 fine. Let's see. That would probably be very problematic, very scripty kind of shape. So it's all about what type of result you're after, but you know, if you need it to be really intricate calligraphy, good luck to you. You're going to spend a lot of time fixing the surface. For my purposes, I'm just going to pick a blocky font like this. This is going to be no problem whatsoever, very, very square shape. Okay. The resulting types, you can do a Nurbs curve if you plan on editing it yourself. Trim, Polygon, Bevel. Most cases I'm going to recommend Polygon. This is just like what I showed you with that conversion menu. And you've got the same options down here, standard, fit, general. In this case though, I recommend count because it will spread the detail out evenly over the entire thing, and then it's going to kind of be up to you to delete the detail that's unnecessary and to draw new detail where it is necessary. Although control points can work as well, you'll have to subdivide yourself. It won't create the interior detail for you. So type, poly, count, I'll just leave it at 2000, see what that creates. Hit create, and what you get is a word, a big word here. And you can see it's all subdivided into little polygon faces. Okay. Now it's very, very dense, this one, especially since I set it to 2000 polygons. If you want to optimize this, you'd have to go through deleting these edges and drawing your own edges. Now obviously this word could be very easily made with much, much fewer faces than I've allowed it to have. But for most fonts, you're not going to have such a blocky shape here. It's going to be very inconvenient for the most part. Just really quickly, I want to show you that the way that you interact with this is a little bit counterintuitive. If you click a certain part of it, you will only get one letter at a time. Okay. If you drag over it, you'll get its letter and its curve, which will give it double transformation. So this part controls the letter. Actually, you can see I just broke it. Let me see. If I click up, so if I click on the edge and then click up to go up in the hierarchy, now I've got the apparently locked Bezier curve group. If I click up again, I get the word group. Okay. So if you want to scale and move the entire word, just click on a part and then tap up a few times on your keyboard until you get the entire shape. In that case, I got the entire geometry shape. Let me try one more time. There we go, the entire geometry shape and the entire curve shape. What I would do is the first thing is grab a piece of geometry, tap up, edit, delete by type history, move it, grab this part, tap up a couple times, and delete it. And now you're just left with the geometry itself. And you can do whatever you want to this. Assign shaders to it, extrude the edges so it has some thickness, whatever. Okay. There is an inbuilt option for that in this text menu though. That's the Bevel option. In my experience, this is more trouble than it's worth, but if you want to play around with it and have some fun, feel free. You've got the creation of the bevel at start and end of the letter, the width, depth, distance of it, and then a bunch of options for the type of bevel. Let me just pick one, concave out, and show you what that does. Okay, so you can see it creates this little lip on the side of the bevel in the depth direction, and the rest of the face of the letter is one big n-gon. This can be fine. In fact, it leaves the subdivision up to you, and I think that, yeah, in most cases it leaves much less work in the cleanup. For instance, I could now delete a couple of these edge loops, draw my own to this corner. You can see it's responding rather slowly though for me. It's responding terribly, in fact, because of the n-gon. So if your result is going to be a complicated piece of geometry like this, then this could be a good way for you to go. Generally, I don't recommend it though because of the terrible slowdown in performance that happens when you start trying to edit it, but it can be fine. Okay, so just keep that in mind that this is a way to create things very quickly that are going to need to be solid words in your scene. All right, the next thing I'm going to show you is how to use Nurbs Curves to create a couple specialty items for Nurbs, which you'd then probably want to convert into polygons. The first one is going to be a revolve. For a revolve, we're going to draw half of a vase or a wine glass and then basically spin the thing around a vertical axis to where it creates the object itself. So I'm going to use a CV curve, and I'm going to look in the front orthographic view, and I'm going to attempt to draw it with its base right here on the origin point, extending up and halfway bisecting this central line. Okay, so first point, I'm going to hold X and snap it to the origin point. For my second point, I'm also going to snap it to the grid just so I have a flat bottom to the object. And then just start clicking in a general kind of beaker or vase kind of shape here. Give it a little lip at the top there. Then for the inside, I can either draw the inside so that we have a thickness to this, or I can just snap it to the center here, which is what I'm going to do right there, and hit enter. So that's my general kind of half of a pot kind of shape. I'm going to choose Control Vertex and then just kind of move this stuff around a little bit to get a slightly more accurate look. Slide that one down a little bit, just so that it's what I expected. Make this a bit taller. And this one. All right, so that's going to be fine. So this is the profile of my object here. You can see that it's going to be able to rotate, all right, rotate in this way to create a solid piece of geometry. Up at the top menu, Surfaces, Revolve is what we're going to use. The only real option that's of importance here is the axis that we're going to revolve along. It's set to Y by default, which is correct from the way that I drew it, but you may want to edit that if you want to revolve something in a different way. You can also change the start and end sweep angles so that you don't get an entire revolved vase. You get only a section of it. But I'm going to hit apply. And then when I go back to my perspective view, you can see there's a nice little pot that's been created for me. Okay. So although we could do this sort of thing with our typical polygons method and moving things around and scaling them symmetrically, this is just another way to arrive at it, and it can be a very, very quick way as well. And then finally, what we'd want to do is convert this with our Modify, Convert Nurbs to Polygon menu. Let's just see if the default works out. Yeah, actually for the most part it does, with a little bit of lost detail right around here. And then we'd go ahead and clean up that object to finish it out. Okay, so that's one of the ways that you can use curves and Nurbs to your advantage. The last one I want to show you is a loft, which is a little bit more complicated. For this, I'm going to draw a couple lines or several lines along the grid. And the key here is that you want to draw the same type of line, so the same number of clicks going across the grid, because it's going to take one of the lines and move a surface between that line and the next one and the next one and the next one for as many lines as that you have. So I'm going to draw this line with 8 clicks. 1, 2, 3, 4, 5, 6, 7, 8. Enter. I'm going to do it again. Create CV curve tool. 1, 2, 3, 4, 5, 6, 7, 8. And then finally again, 1, 2, 3, 4, 5, 6, 7, 8. Okay. I made them curvy so that when I stand them up and move them in space, they will create some sort of interesting topology. I'm just going to modify center pivot on all 3 of them so that they rotate from themselves and rotate them 90 degrees. Okay, 90 degrees. And I'll also just move this one upwards so that it gives it a path to follow. The order that you select these curves is going to be important, so make sure you select them in the order that you want them to flow. So I'm going to select the first one, second one, and third one. Go up to Surfaces, Loft, and here's what's created. So this can be a way to create things like tarps or tents or cloth or something like that. Again, this piece of geometry retains its history, so I can move these control vertexes around and get a result right there on the finished geometry. I don't really use this one very much, but it can be useful every now and then. You can make quick and easy curtains out of it, bedspreads, things like that. Yeah, that sort of stuff. Okay? So I think that's really all I wanted to show you. There are other ones here, planar and boundary, that are useful, but really not very much. There's going to be very few instances where you're going to have to use something like that, and that's something that if you want to get into Nurbs modeling, then maybe you should look up and play around with to find out how they work. All of the tool tips down here help you out, and there's bound to be information on using that stuff. Okay, so that's all I wanted to show you guys this week, a bunch of miscellaneous modeling tools for you. Whether you use these or not in a particular project is entirely up to you, but I definitely recommend that you at least practice making curves of certain shapes, and particularly for using it to extrude along a path. That's the most common use I've seen for it. Your homework is going to be to start a small scene, as in an interior environment, complete with furniture and objects and walls and all of that good stuff, fixtures, so that we can render it out as one complete piece of work. This is going to take several weeks, so try to plan out an environment that is plausible for you, not too ambitious but not too small, and contains objects of a variety that you feel you can model accurately. If you pick an environment such as a completely wrecked and demolished interior, be prepared to make lots of pieces of garbage and rubble and pieces of rock and torn things, and if that sounds too intimidating, pick something a little bit more reasonable. For instance, if you're not too confident, I would say pick something which is very high modern, because it tends to be realistic, it tends to be minimalistic, and have materials which are very simplistic, like metals and plastic and such like that. A little bit more ambitious would be something from throughout history, medieval, maybe feudal Japanese, something like that. We're going to try to avoid exteriors though, because that organic matter outside tends to be really complicated and much more challenging for a beginner, but there's no reason why you can't put the occasional potted plant or piece of fruit in your interior environment. So plan that out, and we're going to start working on it this week, and it's going to take several weeks for us to finish it. All right, I will see you guys in class.